Okay, folks, today we're going to take a look at regression analysis. And regression analysis is the idea that you're going to find how certain variables called independent variables react with another variable called the dependent variable. Now, the best way to explain this is to simply start doing it. So with that in mind, we're going to take a look at the data that we have here about stroke risk. Now, this stroke risk is a factor on a scale of 1 to 100, with 0 meaning you have no risk, and 100 meaning that you have an absolute risk. And so, therefore, our risk will be our dependent or y variable. The others will act as x variables, so we'll call them x1, right, x2, and x3. Now you'll notice that x3 is what we call a binary variable. You either are a smoker or you're not. And so we'll call 1 meaning that you are a smoker, 0 meaning that you're not. Normally I would show you how to code this, but we don't have the time, so we'll just code it for you. So let's go back over that one more time. Your risk is your dependent variable. Age, blood pressure, and whether or not you smoke are your independent variables, right? So these are your x variables. Now, regression analysis is actually quite a simple process. What we're looking for is to test the hypothesis that each of these have a positive or negative risk. So we'll start with the hypothesis that we have a positive relationship between age and risk. That is, that we assume the older you get, the higher your risk. And we will put that against the null hypothesis that there is no relationship. Okay? Okay? We'll do that again for each of our variables, right? And so for blood pressure, we assume then that the higher the blood pressure, the higher the risk. So then there's a positive risk between blood pressure and risk against the null hypothesis that there's no relationship. And finally, we look at whether or not you smoke, right? We assume again that there's a positive relationship, right? Versus the null hypothesis that there's no relationship. Okay? So this should be positive relationship. Okay? So, put a little more succinctly, as age increases, risk increases. As blood pressure increases, risk increases. If you smoke, your risk goes up. So these are our hypotheses. We simply need to go through the entire process now, run the regression, and see if there's any information we can glean. So we go to data, data analysis, regression, data analysis, regression. Click OK. The Y range is going to be everything under the risk. So that's going to be A1 through A61. And the X range will be all three together. The age, blood pressure, and smoke together. Check the box that says labels because we actually did grab the labels here. Confidence levels 95% because we want to be 95% confident in our answer. Now, if we're 95% confident, that means that our alpha, or acceptable risk, is only 5%. My output range, we'll put that just below here in cell G12. Click OK, and it'll run our regression. First thing I look at is this significant F. So the first thing we look at is the significant F, right? The significant F tells me that we have a positive relationship. In other words, this is a good model. That number 4.1 times e to the negative 25, if it was rounded to the nearest 4 decimals, would be 0. Because that number is less than or equal to 0.05, we assume a good model. That means that all three of these together do a good job of predicting what the risk would be. The second number that we look at is the adjusted R squared. The adjusted R squared. Okay? So we're going to take a look at the adjusted R squared, and this gives us our explanatory power. That is, how much do these three together explain the risk? So if we were to round this to the nearest 2 decimals, we see that it becomes 0.87. That means that these three together explain roughly 87% of the risk. So the age, the blood pressure, whether or not a person smokes, that accounts for approximately 87% of the risk. Some of the other factors that might go into that would be diet, whether you have too much salt, right? Other environmental factors, such as where do you live, do you have any injuries, things of this nature. Those are things we can't really account for, but age, blood pressure, and whether or not you smoke can be quantified, all right? Next thing we take a look at are the p-values. And so we're going to round these to the nearest 2 decimal places. Let's increase that to 4, actually. And so when we look at these p-values, we can see that they are all less than or equal to alpha, right? So less than or equal to alpha, in this case, 0.05, we reject the null hypothesis. Okay? We reject the null hypothesis. Now, the intercept, good job. Age. The p-value here is 0.0000. That means then that we have less than 5% chance of making an error, specifically a type 1 error. So we can reject the null that says there's no relationship between age and risk, and therefore we can conclude that we do have a positive relationship between age and risk. We take a look at blood pressure and smoker, and we see that the p-values there are again less than alpha. So that means then that we can reject the null on all of them. And so what we find is that there's a positive relationship between age and risk, a positive relationship between blood pressure and risk, and a positive relationship between smoking and risk. When we look at the coefficients, we can clearly see that that is the case, right? As age goes up, if you increase age by 1 year, the risk of a stroke goes up by 1.07 percentage points. If we increase blood pressure by 1 point, then the risk of a stroke goes up by 0.25 points. But if a person is a smoker, then the smoking risk has the highest effect. Being a smoker means that the probability or the percentage point increases by 8.7 points. So let's round those to 2 decimals, right? Let's round these to 2 decimals to make them easier to read. Let me blow them up a little bit, and you can clearly see that being a smoker is the thing that has the highest positive risk. So if you see a question that asks you which one of these has the highest risk, or which one of these is the most significant factor, you look at the coefficient. Let me say that one more time. To find the one that has the most significant factor, you look here at the coefficients. The absolute value of the coefficient will tell you the one that has the highest impact on your Y variable, on your dependent variable. So being a smoker is the thing then that gives us the greatest impact. So let's put this into a real world scenario. If you're a doctor and you have a patient in front of you who has high blood pressure, the number one thing you're going to tell them to do, or excuse me, you're trying to reduce their stroke risk, the number one thing you're going to tell them to do is stop smoking. Now, part of that is because they can't get younger, so there's nothing you can do about that. You can work to decrease their blood pressure, but you can work and work and work and work, and you're still not going to have a solid understanding of what they're needing to do. You're going to work so hard and you're not going to have the reward. So telling them to quit smoking and working with them to stop smoking will greatly reduce their risk of a stroke. Now, let's put in some other numbers that we can find out. So we want to now use this as a predictive model. If we were to type all of this out, the way this would work would be our risk would be equal to a negative 91.76, and I'm getting that number from the coefficient for the intercept, plus 1.08 times age, right, plus 0.25 times the blood pressure, plus 8.74 times smoker, plus some error term. That error term is the unexplained, and it is the amount that is not adjusted here, so it'd be approximately 13%. Okay? Those are other factors that make a difference. So, as we're taking a look at this, we can plug this in and make an equation. So we have factors and we have coefficients. Excuse me, I put that in the wrong spot. We have our factors and we have our coefficients. Okay? All right. For the intercept, the factor is always going to be 1. Now let's assume we have a person who's 48 years old, whose blood pressure is 168 and they smoke, right? So 48, 168, and yes, they smoke. So now we have the different factors that we plug into each piece. Okay? Again, the intercept always has a 1. Person's 48 years of age. Last time they had their blood pressure checked, it was 168, and they smoke. To find out their risk, what the risk is, we simply take the sum product of the factors times the coefficients. So we take the sum product of the factors and the coefficients. And when we put all those together, we can see that this person needs to stop smoking, right? All right. So we put all those together. We find out that a 48-year-old person with a relatively everything else being healthy has high blood pressure and they smoke, they have a factor of approximately 11. Now, the number one thing that we have to develop from this is how we can reduce that. So if we have an 11 and the person stops smoking, you can clearly see that their risk factors drop by 8.74 points. So the number one thing you would want to do is tell them to stop smoking. Okay? All right. Now, let's go back over that one more time, right? And see if we can pull out any other information. Okay? So, one more time from the top. Step 1, formulate your hypotheses. This is your best guess or your educated guess as to what you think the relationship is between your X and your Y variables. Step 2, run your regression analysis by going to Data, Data Analysis, Regression, and inputting your X and Y ranges. Step 3, take a look at the significant F, and if it is less than your a priori or before the fact alpha, then you know you have a good model. So here, this number is less than 0.05, so we assume a good model. Then we take a look at our explanatory power and see that we have 87% explanatory power, meaning that age, blood pressure, and smoker have a significant impact on your stroke risk. And then we look at each individual piece by evaluating the p-value. And if p is less than alpha, we reject the null. Okay? If p is less than alpha, we reject the null hypothesis. One more time, if p is less than alpha, we reject the null hypothesis. Each of the p-values are less than alpha, so we can reject the null hypothesis on all three. The hypothesis that said that there's no relationship is rejected, so we see a positive relationship between age and risk, a positive relationship between blood pressure and risk, and a positive relationship between whether you smoke and your risk. The next thing we do is building the model, and so we put this model in, and we can pull each of the pieces together. And then after that, we can simply say, here is the factors that take a look. And so if a person is, again, there's a 1 that goes in the intercept, and if a person is 48 years old, has high blood pressure, and they smoke, they have a relatively high risk at 11%. Okay? Thank you very much, and enjoy your day.